Welcome to a lesson on determining the least common multiple of two terms. The least common multiple or lowest common multiple, identified by LCM, of two rational numbers a and b is the smallest positive rational number that is an integer multiple of both a and b. Since the LCM is a multiple of a and b, it can be divided by a and b without a remainder, and the LCM is the smallest number where this is possible. Let's try to illustrate this idea. Let's say we want to determine the least common multiple of 4 and 6. What we could do is start listing multiples of 4, as we see here, and then list multiples of 6. Then what we could do is identify the common multiples, or the numbers that occur in both of these lists. So we see 12 occurs in both lists, so does 24, so does 36, 48, and so on. So these would be the common multiples as we see listed here. So the least common multiple of 4 and 6 is simply the smallest one of these, which would be 12, as we see here, and we also see up here. So if we want to determine the LCM, or least common multiple, of 6 and 8, we could start by listing multiples of 6, and so on. Again, notice we're just adding 6 each time, or you could think of this as 6 times 1, 6 times 2, 6 times 3, and so on. Now we'll do the same for 8. 8, 16, 24, 32, 40, and we just keep listing these until we find a number that these two lists have in common, and we want the smallest of those common multiples. And we can see from our list, 24 is the smallest number that these two lists of multiples have in common, so the LCM is equal to 24. The method of writing out multiples is only practical for determining the LCM of small numbers. As a result, we have a different way to build the LCM of two numbers or terms by analyzing a term's prime factors. And here's the key. The least common multiple must contain all of the different factors in the terms, and each factor must be repeated the maximum number of times it occurs in any one of the terms. So what we'll do is find all of the prime factors that occur in each of the numbers, and then use it the maximum number of times it occurs in any of the terms' prime factorization. Let's go ahead and give it a try. We want to determine the LCM of 24 and 30, so we're going to write out the prime factorization of each of these. Well, 24 is 8 times 3. I know 8 is 2 times 2 times 2. 30 would be 6 times 5, and 6 is 2 times 3. Again, if I lost you here, the way you could obtain the prime factorization would be to take one of the numbers and make a prime factorization tree. 24 is 8 times 3, 3 is prime. 8 would be 4 times 2, 2 is prime. 4 is 2 times 2. So the prime factorization is 2 times 2 times 2 times 3. And we could do the same for 30. Okay, now here's the procedure to build the LCM. We will first list all of the different factors from both prime factorizations. Notice the prime factorizations contain factors of 2, 3, and 5. Now we're not done. We have to determine the most number of times that any of these factors occur in either of the prime factorizations. So what we mean by that is this has 3 factors of 2 and this has 1 factor of 2. We have to take the most number of times the 2 occurs in any of these prime factorizations. That would be 3 times. So we need 3 factors of 2. Next we look at the factor of 3. It occurs once here and once here, so we only need it once. And now we'll look at the factors of 5. It occurs 0 times here and 1 time here, so we need 1 factor of 5. This is how we build the least common multiple of 24 and 30. Now we can multiply this out. It should be 2 times 2 times 2 times 3 times 5, which is equal to 120. So the LCM of 24 and 30 is equal to 120. Let's go ahead and try another. Now notice on this example we're introducing variable factors, but that's okay. The procedure is going to be exactly the same. Let's go ahead and write these out in prime factored form. So 27x squared y squared would be 3 times 3 times 3 times 2 factors of x and 2 factors of y. If you're puzzled by where the 3 times 3 times 3 came from, again, it came from making a factor tree for 27. So we have 3 factors of 3. 15 would be 3 times 5, x cubed, so 3 factors of x, and 1 factor of y. So now we'll build the least common multiple. We'll first list all of the different factors that are used. Let's look at these factors first. We have a factor of 3 and a factor of 5. We also have factors of x and factors of y, so we have to include these factors. Now we're not done. We have to go back and determine the most number of times these factors occur in either of these factorizations. So we have 3 factors of 3 here and 1 factor of 3 here. We have to have 3 factors of 3 in our least common multiple. Next, there's 0 factors of 5 here and 1 here, so we need 1. Now let's look at the factors of x. There's 2 factors of x here and 3 factors of x here. We have to take the most that occur in either of the 2 factorizations, so we need 3 factors of x. Y occurs twice here and once here, so we need it twice. Be careful not to add the number of times the factor occurs. You just take the most number it occurs in either one of the lists. So the result would be 3 to the third, that would be 27. 27 times 5 equals 135. Then we have x cubed y squared. Let's try another. We'll begin by writing out each term in prime factored form. For 60, we'd have 6 times 10. 6 is 2 times 3. 10 is 2 times 5. So we have 2 factors of 2, 1 factor of 3, and 1 factor of 5. We also have 5 factors of m and 2 factors of n. For 72, that would be 8 times 9. 8 is 4 times 2. 2 is prime. 4 is 2 times 2. And 9 is 3 times 3. So we have 3 factors of 2 and 2 factors of 3, as well as 2 factors of m and 4 factors of n. Let's go ahead and build our LCM. Let's first list all of the different factors that are used. That would be a factor of 2, 3, 5, m, and n. Now let's go back and determine how many of these factors we need. This has 2 factors of 2, this has 3, so we need 3. This has 1 factor of 3, and this has 2, so we need 2. This has 1 factor of 5, this has 0 factors of 5, we need 1 factor of 5. We have 5 factors of m here and 2 here, so we need 5. And we have 2 factors of n here and 4 here, so we need 4 factors of n. So 2 to the third, that would be 8. 3 squared would be 9. 8 times 9 is 72 times 5, that's 360. M to the fifth, n to the fourth would be our LCM. I hope you found this video helpful. Thank you for watching.